Okay, hi, good morning. Am I audible? Please check so that we can start. Okay, so last time we had seen something called as chemical effects of electric current, and we had also seen that there are certain uh, things like suppose let's say there is electrolyte, there is electrolytic cell, it's an apparatus, we have electrodes, and we have seen there is a chemical reaction called as electrolysis. So electrolysis is being used for what exactly? It is being used for the breakdown of the liquid electrolytes, correct? That is what we had learned last time, that electrolysis is nothing but breakdown with the help of electricity. So that is called as electrolysis. So that's a chemical reaction what we had seen last time. Now today what we are going to do is we are going to see two electrolysis. One electrolysis we are going to go for is first is basically water. First electrolysis that we'll be seeing today is electrolysis of water. Okay. Now let us talk about this. But before we get into the details, can somebody tell me the formula for water? If somebody can give me a simple formula for water, that would suffice. The formula is H2. Correct? Water is nothing but H2O. But according to your information, does H2O, suppose let's say, we'll take H2O in the container. Okay, first we will take that H2O in the container. So let me take that. We'll use the same diagram which is there in your book. Okay, so we are using this particular diagram. So this is the diagram, right? Okay, so this is what is present in your book, correct? Okay, but according to your information, suppose let's say this is our battery, we have connected anode, we have connected cathode, and above that anode and cathode, what we have done is we have kept inverted test tubes. What we have kept here is inverted test tubes. So these are inverted test tubes. So let me just write it down there. So these are inverted test tubes, inverted test tubes. Okay. To collect gases, what we have done is we have inverted the test tubes and we have exactly kept it over where? Over that anode and cathode. We have kept those our test tubes inverted over anode and cathode so that whatever the gases are released, that will be taken. But according to your information, this is water, right? This is water. According to your information, does water carry electricity? Like pure water? What do you think? Does pure water carry electricity? No, right? Okay, it's not an electrolyte. So if it is not an electrolyte, then you need to make it electrolyte. You need to make it. And how can we make it? By adding impurities. And what is the best impurity you can add? You can add acid inside it. You can add acid inside it and then it will become electrolyte. So water is not an electrolyte. Water, not an electrolyte. So what you are adding? Sulfuric acid. Add sulfuric acid to make it an electrolyte. Sulfuric acid. Technically you can add any acid. Huh? You can add even sulfuric acid, you can add nitric acid, you can add HCl also, hydrochloric acid. That is up to you. Any kind of acid will do. So you just acid you are adding so that you can make it into electrolyte and then the electrolysis reaction is going to happen. Now question is, after the reaction, who is going to, suppose let's say, release at what? So according to the diagram, can you please tell me by looking at the diagram, who is depositing at anode and who is depositing at cathode? So you have to remember, as soon as the electricity is flowing through the our electrodes, when we are turning on the electricity, we are using the battery electricity. That electricity is going to flow through anode and cathode, and what is going to happen is electrolysis of water is going to take place. Now who is going to deposit at anode and who is going to deposit at cathode, that you should remember. So which are the two gases? At anode, oxygen is going to liberate. At anode, oxygen is going to liberate, and at cathode, hydrogen is going to liberate. Okay, are you understanding this? Anode is going to be, who is going to liberate at anode? Oxygen. And who is going to liberate at cathode? Hydrogen. Now problem is that your class, which is 8th, you don't have the details regarding this, like exactly why oxygen is going towards the anode or cathode, like hydrogen is going towards the cathode. There are actually lots of good reasons, but I will be able to teach you this only in class 9th or maybe in 10th. This is not there in your syllabus, like why exactly this happens. That is in your 9th, or suppose let's say probably in 10th I will teach you. But right now you just have to remember that anode oxygen is being released on anode and hydrogen is being released at cathode. That is what you should remember. Okay, but I will just tell you one short trick. I will just tell you one short trick so that you will always remember this. Okay. Okay. So one thing you have to remember is at anode, generally non-metals are deposited. Non-metals. Okay, and at cathode, metals are deposited. The reason being because cathode metals are generally positive. Generally they are positive. They like to donate electrons. Metals are very much positive, and cathode is negative, right? So that is the reason why metals get attracted towards the cathode. The reason is that metals are positive, cathodes are negative, and because of that positive charge is going to be attracted to negative charge. So that's why cathode will always have metals and anode will always have non-metals, because non-metal, anode is nothing but positively charged, non-metals are negatively charged, so that's why they are going to be attracted to anode. Are you understanding this simple logic? Anode is going to attract non-metals, cathode is going to attract metals because of the opposite charges they have. Okay, I hope this point is clear. This is just a short simple logic I am telling you. This is not in your syllabus, but still I am telling you. You just have to remember according to your 8th syllabus. You just have to remember like which gas is being released at which electrode, like anode and cathode. That is the only point they are expecting. But I am still giving you additional point. So if you are not understanding this, that is totally fine. But I am giving you one simple trick to remember. Additional trick. This is not in your syllabus. This is just an additional trick. Okay. Now let us move ahead. Can we suppose, let us say, take this particular diagram and we will discuss something more. We'll take this diagram down and we'll discuss something more. Okay. Now have you observed that hydrogen content has been shown more? Can you see the content of hydrogen is very much more as compared to oxygen. H2 has been shown more and oxygen has been shown less. Can you see? Oxygen has been shown less. Okay, what might be the reason? The reason is very simple, because in your formula, in your water, the formula is H2O. So that means there will always be 2 atoms of oxygen. After the breakdown, we will get 2 atoms of hydrogen. That means 2H2, and we will get 1 atom of oxygen. Are you understanding this? That we are getting 2 atoms of hydrogen and we are getting only 1 atom of oxygen. That is why the quantity of hydrogen we are getting will be double than that of oxygen. Then that will be double. This quantity is double as compared to the quantity of oxygen. So that means if we are getting oxygen as 10 kg, if we are getting oxygen as 10 kg, hydrogen we will get as 20 kg. We will get hydrogen as 20 kg. Are you understanding this? Okay, that's a very simple explanation what we have. This is also not in your syllabus, but just I am giving you an observation. Okay, so now let us revise. So electrolysis of water, let us revise it. Who is going to deposit an anode? Just give me answer for this. Who is going to deposit an anode? Oxygen. Oxygen is going to deposit at anode. And what about cathode? Who is going to deposit on cathode? Hydrogen. Hydrogen is going to be deposited on cathode. The reason being oxygen is a non-metal. Oxygen is a non-metal. And hydrogen, even though it's a gas, it has metallic character. That is one of the reasons that why it has been kept above sodium in the periodic table. So for now, even though it's a gas, you can say exactly it's not a metal, but it has metallic character. It's not a metal, but it has a metallic character. That's why it is attracted to cathode. That's why I told you, remember that metals are attracted towards the cathode because cathode is negative and metals are positive. ठीक है? In the same way, anodes are positive and they will get what? Non-metals. This is the simplest trick you can use. That is the simplest trick you can use. Okay. Now, can you please suppose, let us say, we'll go for one of the another electrolysis, but this time you have to use logic. Okay? Whatever the logic I have taught you, you have to use the same logic for electrolysis of copper chloride, and you have to give me the answer. Is it fine with you? Will you be able to give electrolysis of copper chloride? We will just use your logic. Okay? Whatever I have taught you, it's the same trick you have to use here. Okay. So electrolysis of copper chloride. So this is the substance we are going to add inside the water. Then we are going to add acid inside it. Okay? Some kind of acid. And after that, you just have to tell me, we are going to get two substances, right? Copper chloride. Can I write down something like this? Copper chloride, when electric current is passed through it, electric current. So we are getting, what we are getting? We are getting copper and chlorine. Copper and we are getting chlorine gas. Copper plus chlorine. Now you tell me, what is copper? What is copper? Copper is a metal or non-metal? According to your information, copper is a metal or non-metal? It's definitely a metal. If it is that, it is definitely a metal. Okay. What about chlorine? What about chlorine? Chlorine is definitely a non-metal. Chlorine is definitely a non-metal. Correct? It's a gas. It's a non-metal. Now you tell me who is going to deposit at anode and who is going to deposit at cathode. Okay. But for that we should have information, right? Cathodes are negatively charged, anodes are positively charged, metals are positively charged, and non-metals are negatively charged. Now metals being positively charged will be attracted towards the negative charge. So metals are positive, they will be attracted to negative, and who is negative out of them? Cathode is negative. So metals will be attracted to this, and who is that metal? Copper. So metals are going to be attracted to cathode and anodes will be attracting non-metals. And in our example, who is the metal? Copper. So copper will be depositing at cathode and chlorine will be depositing at anode. Are you understanding this? How to find out whether which material is going to deposit at what electrode? So simple. Okay, I think this particular description what I have given you, that will definitely help you out, right? Okay, understanding. Okay, can we do one thing? Can we take another example? If you are interested, I can take another example. Okay, so let me have that. Another example we are going to take is iron iodide. Okay, we are seeing, this is not in your book, but we are just taking one more example. Electrolysis of iron bromide. Okay, iron bromide. This is not in your syllabus, but I am just taking one example so that you can understand more deeply. Now when iron bromide is supplied with electricity, it is going to divide into electric current. It is going to divide it into iron plus bromine gas. Iron plus bromine gas. Okay. Now according to your information, what is iron? Iron is a metal or non-metal? What do you think? Iron, according to your information. It's a metal. Of course it's a metal. It is widely used metal. Okay. And what about bromine? Bromine is a non-metal. Bromine is non-metal. Okay, so this is positively charged, metals are positively charged, non-metals are negatively charged. Now you tell me who is going to deposit at anode and who is going to deposit at cathode. Anodes are positively charged, cathodes are negatively charged. Okay, so it will be attracting negatively charged particles, that is non-metal. Correct? And cathode is going to attract positively charged, that is metals. Who is metal in this case? Metal in this case is iron. Okay, and anode is having what? Bromine. Non-metal is bromine. Okay, are you understanding this? Like how to find out? I hope everybody has understood how to identify who is going to deposit at what place. Okay, good. Now, can we move on? Can we move? Okay, fine. Now, I just want to ask you one question. Suppose, I'm just giving you a simple example. Fine. Okay, now I have one electrode. Okay, I have one electrode. This is the one. Okay, so this is anode and this is cathode. Okay, this is cathode. Okay. Now, can you tell me one thing? Like suppose let's say this is positive, this is negative, this is anode and this is cathode. In our example which we took, just like iron bromide, who had deposited a cathode? According to our information, when we took iron bromide, who deposited a cathode? Cathode is negatively charged. It is going to attract positively charged particles, and those are nothing but iron. So cathode is going to attract whom? Iron. Now can we talk about exactly what happens to that iron? Let us talk about that, because we just said that cathode is going to attract iron, but we have not said what is going to happen with it. So what is going to happen with it is that iron is going to deposit on cathode. Okay, so this whatever this electrode is made up of, it is going to have a layer of iron. This is what is going to happen. So can we say if metals are there, so that means basically they are creating a layer on cathode. So cathode will get a new layer. It will get. And what about anode? Anodes are getting non-metals generally. So that non-metal basically is a gas. In our case it was a gas. So anode is not going to have a layer of gas. Gas will be released. So basically it will just have some dots. If you want to collect them, if you want to collect this particular gas, you can do one thing. You can put one inverted test tube over it. Like this. Okay, and then you will be able to collect that gas. Okay, but basically it is not going to create a layer, because gas cannot create a layer. Metals can create a layer. So can we say that cathodes are generally creating the layer? On cathodes, a layer is going to be formed of metal. A layer will be formed. Agreed with this? A layer will always be formed. Okay. Now I want to ask you one simple question. Suppose I have silver inside a liquid. Okay. I have silver inside a liquid. I'm just giving you a simple example. So I have lots of silver here, lots of silvers. Okay, and I have two electrodes here. This is my first electrode. This is anode. This is anode. This is A, right? And this is cathode. This is C. Okay, this is anode, and this is cathode. Now you tell me if this is silver solution, silver chloride solution. Can you tell me silver is going to deposit on which material? Like which electrode? Whether it is going to deposit on anode or whether it is going to deposit on cathode. Silver. If this is silver solution, if I am passing electricity through this, according to your information, where is silver going to deposit? Just write it in the comment section so that I can understand according to your information. Okay, so silver is nothing but a metal. Silver is nothing but a metal. So metals are going to deposit on cathode. So exactly what is going to happen is that silver is going to be deposited on cathode and we will get a layer on cathode itself. Right? We are going to get a layer on cathode. Understood? Exactly. That is so true. That is so true. You have understood the concept. Congratulations. So what we are trying to do is basically just write it in the comment section whether it is fine with you. Okay, so yes, that is the logic we are trying to understand. Now have you let's say heard about this, that there are certain metal pieces, like for example there are spoons which are made of gold, spoons which have a layer of gold, or even suppose let's say like some certain some jewelry which your mom has, your mom has some jewelry, right? That jewelry also has a layer of gold or sometimes silver, sometimes platinum. Okay, so the question is, can we achieve that? Yes, definitely we can do it. Okay, so now you tell me, suppose if I have a container, I have a big container and it is full of gold. Now I'm asking you, I want to suppose, let us say that is this particular layering method, it is called as electroplating. That means you are adding a layer of a metal over another metal. You are adding a layer of metal on another metal. Okay, so I'm just asking you, if I want to put a layer on spoon, where should I connect that spoon? Should I connect it to anode? Or should I connect it to cathode? What do you think? If I want to put a layer of gold on spoon, where should I attach this spoon? Should I attach it as an anode or should I attach it as a cathode? What do you think? Okay, so this total material is made up of gold. I have a gold solution inside. I just want to put a layer of gold on my spoon. Okay, so where should I put my spoon? Whether should I put my spoon on anode or cathode? What do you think? Okay, exactly. So we are going to put my spoon in cathode. We are going to put our spoon at cathode. Exactly. So we are just going to put it there. Let me just write it down. Okay, so this is my spoon. Okay, this is my spoon. I am going to put my spoon on cathode. Why I have put my spoon at cathode? Because if I want to deposit gold, which is a metal, gold is a metal, and it is going to deposit where? On cathode. It is always going to deposit on cathode. So that's why if I want to have a layer on my spoon, I have to attach my spoon to the cathode. If I attach my spoon to the cathode, only then we are going to have that layer of gold. Are you understanding this? It's a very simple concept. But very useful. Okay. Now question is, what to attach to the another rod? What we have to attach to the another rod? What we should attach to the anode? Okay, that is also simple. Your solution, can I say that metals cannot be liquefied easily? Metals cannot be easily liquefied, correct? So what we can do is, instead of taking gold solution, you can do one thing. You can take a normal solution and you can attach your gold bar, your gold which you want to deposit on your spoon at anode. You use electrode of gold, made of gold. So you are going to use anode as a gold. So basically gold electrode you are going to use, gold electrode. Are you understanding? You are using gold in terms of anode. You are not going to use solution. Why? Because solutions are nothing but solutions. Problem is that you cannot create a solution of gold, and that is not easy because you have to supply a lot of temperature, then gold is going to melt, So that is very hard. So instead of that, you are going to attach gold towards the anode, and the material you want to layer on, that has to be attached to the cathode. So in short, what you are trying to do is, the material which you want to suppose let's say have a layer on, suppose let's say you want to layer some spoon, or you want to have a layer on your pen, suppose let us say. So in the same way, spoon, or suppose let's say some nails, you want to have gold plating. Okay, that is called as electroplating. So you want a layer, so you have to attach it to cathode. Okay, and the material which you want to plate, for example, you wanted to plate gold, right? You wanted to have that gold layer on your spoon, then gold has to be attached to the anode. Gold has to be attached to the anode, so that gold will come out of that anode and it will come towards the spoon. It will dissociate, it will divide inside that solution, and it will attach itself towards the spoon. Okay, now let us try to understand with one more example. Okay, so I have a material called as platinum. Okay, I want to have platinum, and I have one iron knife. Okay, I have one iron knife. Okay, now you have to tell me, where should I attach my platinum and where should I attach iron knife? I want to have a layer of platinum over my iron knife. You just have to give me, where should I attach my iron knife and where should I attach my platinum? Okay, iron knife, it has to be attached to cathode. Yes, exactly, it has to be attached to cathode, because on cathode our layer is going to come of the metal. Okay, and platinum has to be attached to anode. Okay, that means in short, the material on which you want to have a layer, it has always to be attached to cathode, and the material from which you are supposed to, suppose let us say you want to have a layer of, that has to be attached to anode. Are you understanding this? Always you have to add, suppose let's say attach the substance on which you want to put a layer. For example, you are putting a layer on some iron piece or some aluminium piece, so you have to always attach to cathode. Okay, are you understanding this? Have you understood this? A simple example. Okay, so this particular procedure is called as electroplating. This procedure is called as electroplating. Okay, so that means putting a layer on a metal. Okay, putting a layer of metal over another metal is called as electroplating. So you can just give a simple definition. Electroplating is a process in which we put a layer of metal on another metal. We put a layer of metal on another metal. Okay, now can we say, now we have different words for it. This is electroplating, but you already know there are different metals which are used for a, suppose let's say plating, correct? So if I use gold, for plating, then it is called as gold plating. That is called as gold plating. Okay, what do you think will be the name if I use platinum? If I use platinum, then what we are going to call our electroplating? We are going to give it a name, platinum plating. Platinum plating. Okay, what if we are using, suppose let us say silver? What if we are using silver? It is going to be called as silver plating. Silver plating. Are you understanding this? Just give me a response in the chat box. Have you understood that what we are trying to do in this case? Are you understanding? Different names are given. Different names are given, nothing more. Okay, so what we are going to do now is we are just going to see some uses and then we are going to discontinue our session for the day. The uses are very simple. You can plate, suppose let's say your jewelry items can be made, correct? Are you understanding this? Jewelry items, cutlery items can be made. Cutlery means the spoon kinds of things. Spoons, your basically utensils of the kitchen, those are called as cutlery items. So cutlery items can be made like, they can be having a layer of gold, right? Okay, so they can have gold plating. They can have gold plating. That is one of the use. Okay, another use is silver plating can be done which on the common items. Silver plating can be done on common items. Whatever the material you want to like, suppose let's say want to have plating of, so you can have silver plating on that particular articles on common things. Okay, let us go for the third use. Okay, have you seen the tin cans? Normal tin cans can be, suppose let's say they can be created by putting a coat of zinc over iron. How they are created? By putting a layer of zinc on iron. Now can you tell me in this case who is going to be anode and who is going to be cathode? In your textbook, can you please write it down? Just in the application of electroplating, can you just write it down there? Okay, so iron will be attached to whom? Cathode, because that is the material on which we want to have a layer, and the material we want to provide is zinc. So zinc has to be attached to the anode, so that it will be distributed inside the solution. It will come out of that anode and it will attach itself towards the cathode. So we are going to attach iron to cathode and zinc has to be attached to anode. So it has not been written there in your textbook. Just write it down before that use. Like, you know, you have ample amount of space there in the applications, in the uses, that is available on your last page, page number 220. Okay, can you please come to page number 220, and on that page number 220 of your textbook, just write down there iron will be attached to cathode and zinc will be attached to anode. Fine. Okay, so that is the one of the last uses you have, and one more use is there, and that is nothing but chromium plating. That's it. That is the last use of the day, chromium plating. Okay, now you might not understand like what is chromium plating. Now let me just give you a simple example of this. You must be having your bicycle. Correct? So in your bicycles, your basically handle, your bell. What do you have? Handle, bell. Okay. Don't you think they shine too much? Correct? Where do you think that shining comes from? It must be something, right, which shines. Basically the shining part of your bicycle, that is nothing but made up of chrome. Okay? That is basically made up of chromium. So that's a chromium plating what you have. So that shining comes from which particular element? Chromium. So that is your chromium plating, which, like, you know, your handlebars of bicycle are made up of, handles of bicycles. Yes, even car bumpers, bath taps. Okay, so even your bath taps what you have are made up of chromium. Like the taps which you have in your on your basins, or suppose let's say one which you have in your bathroom taps, those are also plated with chromium. So we are putting a layer of chromium over it for extra, what I can say, attraction, and also its protection. For protection also, and for also so that we can make it more attractive, more what I can say, shiny. So to make it more shiny, we are putting a layer of chromium. So this is all. Okay. In the next session, what we are going to do is we will be having a separate. Will you do one thing? Can you complete the topic and everything by the, suppose let us say the coming Sunday? We might be having one Menti quiz over it. Okay? By coming Sunday, can you complete it? Complete it by Sunday, by this coming Sunday. We might be having one session over it. We will take a quiz. You will be given 4 options. You have to select out of them. If you are not able to give the answer, then I will help you out. Fine. Okay then. So let us end our session for the day, and we'll meet in the next session. But before we meet in the next session, please complete this lesson, read from first point to last point, and then we'll be having a quiz over it. Is it fine? Okay then. Thank you so much for today.